Welcome to Decision Making class. In this session, I am still going to talk about the example of revising judgment in the light of new information. If you still remember from the stock case, then before implementing the decisions, the retailer received the sales forecast, which suggests that the sales will be high. So, if you are as the retailer, then should the retailer change your mind in the light of the forecast? By using the concept from the theorem Bayes, the conditional probabilities here, then we can represent using the Bayes. In the past, when the sales turned out to be high, the forecast had correctly predicted high sales on 75% of occasions. It can be represented by probability forecast high sales given high sale is equal to 0.75. The probability given at the first is sales turn out to be high. The next, however, in the seasons when the sales turned out to be low, the forecast had wrongly predicted high sales on 20% of occasion. It means that you know about the sales turn out to be low is given at the first. It means that probability forecast high sales given low sales is equal to 0.2. By constructing the decision tree, then we represent the conditional probability here. The first is when the sales turn out to be high, the forecast had correctly predicted high sales on 75% of the occasion is probability high sales given high sales is equal to 0.75. And when sales turn out to be low, the forecast had wrongly predicted high sales on 20% of occasion. It represented by the probability high sales forecast given low sales is equal to 0.2. Remember that the probability high sales forecast given low sales is not the same with the probability low sales given high sales forecast. And also probability high sales forecast given high sales is not the same with the probability high sales given high sales forecast. So in order to this, then we need to calculate again. To calculate, then we need the data about the joint probability. So far, we have the probability low sales and also probability forecast high sales given high sale and also forecast high sale given the low sales. And this is the marginal probability about the probability low sales and the probability high sales. In order to calculate the joint probability, then using the Bayes theorems, the joint probability A and B is equal to probability A given B multiplied by probability B. If we want to calculate the probability high sales forecast and low sales, then is equal to probability high sales forecast given low sales multiplied by the probability low sales. So it means that we have 0.4 is the probability low sales and multiplied by the probability high sales forecast given low sales is equal to 0.2. Then we got 0.08. Also, the same with the probability high sales forecast and high sales is equal to probability high sales forecast given high sales is equal to 0.75 multiplied by the probability high sales 0.6. Then we got 0.6 multiplied by 0.75 is equal to 0.45. Then we can calculate the joint probability. The joint probability for the high sales forecast is equal to probability high sales forecast high sale and probability low sales and forecast high sales is equal to 0.45 plus 0.08 is equal to 0.53. So after we got the joint probability, then we calculate the posterior probability. Then we calculate probability high sales forecast given low sales is not the same with the probability low sales given high sales forecast. So, we need to calculate the probability low sales given high sales forecast is equal to probability high sales forecast and low sales divided by the probability high sales forecast. So, it's equal to 0.8 divided by 0.53. We got 0.15. Also the same, probability high sales given high sales forecast is equal to probability high sales forecast and high sales divided by the probability high sales forecast. In this case, we got 0.45 divided by 0.53, so we got 0.85. So after that, then we got the posterior probability here. Probability high sales given forecast high sales 0.85 and the probability low sales given forecast high sales 0.15. And for the forecast high sales, we got 0.53. So by adopting this probability value, then we can construct the new decision tree like this. At the beginning, then we got the prior probability for the low sales is 0.4. Then after we get the new information, then the probability of the low sales given the forecast high sales, then 0.15. And also the same. So the expected monetary value for the small stock, then we got 0.15 times to 80,000 plus 0.85 times to 140. Then we got $131,000. From this, then also we got the expected monetary value for the large stock. We got $190,000. From this, then the decision here it still hold the large stock. Then how we can draw all of the complete decision tree? For all complete the decision tree here, then whether we try to forecast or do not forecast. As we know that if we don't have a forecast, then we call it as the basic information. Our decision here is to hold the large stock. And also if we want to do the forecast, then forecast say the low sales, then what about the new probability for the posterior probability? After we calculate, then we get the new probability as the posterior probability. And as the previous calculation, then if the forecast say high sales, then we calculate for the low sales. Given the forecast high sales is 0.15 and the high sales given the forecast high sales is 0.85. From this, then we got still the forecast say high sales. Then after this, then what is our decision? Whether to do the forecast or to not to do the forecast. From this, then we compare between the maximum expected monetary value, do forecast or do not forecast. Then we got the forecast as the decisions. So here about the value of new information as the source of the revising the judgment from the previous one. Thank you very much and see you again for the next session in the decision tree with the value of new information with the imperfect information. See you!